Hello everyone. Today we are still moving on with our stoichiometry. We'll be looking at limiting reactants today. Before we move on, let's look at the standard we're going to address. We are looking at standard 3E, obtain, evaluate, and communicate information about how the law of conservation of matter is used to determine chemical composition in compounds and chemical reactions. Plan and carry out an investigation to demonstrate the conceptual principle of limiting reactants. For today's lesson, we are going to look at our learning target, which is I can identify a limiting reactant and excess reactant with the amount of products produced. An assessment method will be our ability to identify the limiting reactants, excess reactants with the amount of product produced. Alright, let me take you back to our daily activity. Supposing you are working in a restaurant and you are a waiter. You are going to host a couple of people coming to your restaurant and you are going to set a table or as many tables as you can. For each table, there must be one plate, one fork, one knife, and one spoon. And you have 5 plates, 6 forks, 4 spoons, and 7 knives. How many table settings can you make from this? And then, what is the limiting item? Which item is the limiting one that limits you or that runs out first? If you say 4 sets of table, that's correct. Because your spoon runs out after you've made the 4th table. So that means your spoon here is your limiting item. So, let's look at the definition of a limiting item. A limiting reactant in a chemical reaction is the substance that is used up first, just like your spoons were used up first. It stops the reaction and limits the amount of product that can form. You could not continue with your formation of your table set because you run out of spoon. So it limits you to only 4 sets of table. Alright? Another example is how many peanut butter sandwiches could be made from 8 slices of bread and 1 jar of peanut butter. I hope everybody knows how to make a sandwich. Alright, with 8 slices of bread, only 4 sandwiches could be made. The bread is the limiting item because you run out of bread. After making 4 sandwiches, you don't have any slice of bread left over. But you still have excess peanut butter in the jar. So your bread is your limiting item and your peanut butter is your excess. Let's look at another example. How many peanut butter sandwiches could be made from 8 slices of bread and 1 teaspoon of peanut butter? So in this case, you have only 1 teaspoon of peanut butter and you have 8 slices of bread. So you can only make only 1 peanut butter sandwich. So your bread in this case stands for your excess. You have excess bread. So your peanut butter is your limiting reactant or limiting item because it limits to only 1 sandwich. Let's look at the steps in solving limiting reactants. Step number 1 is to write a balanced equation. Step 2, For each reactant, calculate the amount of product formed. Step 3. Smaller answer indicates a limiting reactant and the amount of product formed. Alright? So let's look at first chemistry example. When 4 moles of hydrogen is mixed with 2 moles of chlorine, how many moles of hydrochloric acid can form? You have 4 moles of hydrogen, 2 moles of chlorine, but you want to find out how many mole of HCl can you produce. Calculate the moles of product from each reactant. That means you are going to calculate the product you are going to get from each reactant. So step 1, you use hydrogen, 4 moles of hydrogen, to know how many of HCl are you going to get. Step 2, you use 2 moles of chlorine again to see how many HCl are you going to produce. So the one that gives you the smaller amount will be your limiting reactant. So let's go back to the calculation side. Right, so just copy the question right here. So you have 1 mole of hydrogen here, 1 mole of chlorine to give you 2 moles of HCl. So the mole ratio is 1 to 1 to 2. Alright. So let's start from hydrogen. Remember, whatever you are given comes first. So 4 mole of hydrogen goes down here. And remember, the first thing to do is to write the units at the bottom as well, so that you know this will be your conversion factor. So if your mole of hydrogen is at the top here, you must have mole of hydrogen at the bottom. Then the next thing is to look at the mole ratio. Mole ratio of hydrogen here is 1. And whatever you're looking for, remember I told you, always comes to the top. You're looking for how many moles of HCl can you produce. So that HCl comes to the top. So the mole ratio of HCl is 2 from the balanced equation. So we multiply the top divided by the bottom. Meanwhile, the unit cancels the unit, that is mole of hydrogen, cancel mole of hydrogen. If you discover that your unit does not cancel, that means there is something wrong with your unit, or there is something wrong with your conversion factor. So the first product we get here is 8 mole of HCl. Let's look at chlorine. We are given 2 moles of chlorine. Right? 2 moles of chlorine goes here. Remember, the mole of chlorine also goes to the bottom so that they can easily cancel out. Mole of chlorine will cancel mole of chlorine. And meanwhile, this number is the mole ratio. This is the mole ratio of HCl which you are producing. So what you are going to do, you are doing is you are producing the same products with the 2 reactants differently. Alright, so when you use chlorine, you now discover that you are able to produce 4 mole of HCl. So this is the smaller amounts. So in this case, you can only get 4 moles of HCl because your chlorine is your limiting reactant. Limits reactant, limits your products. So you cannot get 8 mole of HCl because you are out of chlorine. Once you produce 4 moles of HCl, the reaction will stop. So in this case, your limiting reactant is chlorine because it is used up first. You don't have any chlorine left over, so you cannot produce HCl any further. As soon as you get 4 mole of HCl, the reaction will stop. Alright? So the limiting reactant here is your chlorine, because the chlorine produces the smaller amount of HCl. Let's take another example. Now, get a pen and pencil and let's work this one out. If 4 points, let me write the balance equation. 4.80 mole calcium mixed with 2 mole of nitrogen. Which is the limiting reactant? How many moles of calcium nitride are formed? What is the excess reactant? The balance equation is given as 3C Ca, that is 3 moles of calcium, plus 1 mole of nitrogen to produce 1 mole of calcium nitride. Remember, you have 3 moles of calcium, 3 moles of calcium, 2 nitrogen, 2 nitrogen. So let's move on to the first step. We want to produce calcium nitride from calcium. Okay, remember you are given 4.8 mole of calcium. Now I want you to pause this problem, solve it before you move on to the solution. Alright, so 4.80 mole of calcium is given in the question. That goes first. Remember, the mole of calcium will also be at the bottom here so that it can easily cancel out. And the calcium nitride is what we are looking for, which is this. How many moles of calcium nitride? So that goes to the top. Now this is the mole ratio. 1 for calcium nitride, 3 for calcium. So 4.8 times 1 divided by 3 will give you 1.60 mole of calcium nitride. Alright, mole of calcium or calcium mole of calcium as usual. Let's take the second reactant, nitrogen. So we want to see how many calcium nitride can we get if you use 1 mole, if you use 2 moles of nitrogen. Okay, 2 moles of nitrogen goes first to the left hand corner. Remember, mole of nitrogen will also be at the bottom so that they can easily cancel out. Mole of N2 cancel mole of N2. So the mole ratio is 1 to 1 from the balance equation, 1 to 1. So that's 1 to 1. 2 times 1 over 1 will give us 2 moles. So in this case, you have 2 mole of calcium nitride produced. Which one is the smaller one? 1.6. So which reactant produced the smaller amount? It is calcium. So in this case, calcium is your limiting reactant because it produces the smaller amount of 1.6 mole. The second question is, how many moles of calcium nitride are formed? Of course, 1.6 mole is the only one you can get. You cannot produce this because you already run out of calcium. Once you produce 1.6 mole of calcium nitride, reaction will stop because there will be no more calcium left over. So, of course, once your calcium nitride is formed, 1.6 is formed, reaction will stop. So your calcium is your limiting reactant. 1.6 mole of calcium nitride is formed, and then the excess is your nitrogen, which is your leftover. Of course, once you have 2 reactants, if you have gotten your limiting reactant, automatically the second one is your excess. Alright, this should be enough for you to work out the remaining problems I'm going to give you. Please make sure you pause this video and work them out properly. Any question, you can chat me up in Google Classroom. Alright, one more example using the mass problems. Calculate the mass of water produced when 8 grams of hydrogen and 24 grams of oxygen are reacted together, and what is the limiting reactant. So out of these two, which one runs out first? So let's go back to our calculating room. Get your pen and pencil and work it out. Remember, this is mass to mass. Our previous video explained mass to mass calculation. So if you have forgotten, please go back to the previous video on mass to mass or grams to grams to understand it better. Alright, you can pause this video so that you can work it out on your own before you continue with the solutions. Alright, you start with hydrogen. You have 8 grams of hydrogen. So 8 grams of hydrogen goes to the corner here, hydrogen. 8 grams goes here, and the grams of hydrogen will also be at the bottom. Remember, hydrogen is diatomic, 1.08, so that will give us 2.016 times 2. That will give us mass of hydrogen, which is the atomic 2.016 grams. So that's this section here is your grams. Remember, this is grams to grams. We are using grams now to determine our limiting reactant. So you start with the grams. This will be your grams. You converting these grams to mole. Then this section will be your mole ratio, and then this is the section to convert back to grams. So your grams of hydrogen crosses the grams of hydrogen. Now, because you have mole of hydrogen right here, you have mole of hydrogen here as well. What are we looking for? We're looking for water. So H2O will be at the top. And this is your mole ratio section. So you now go back to your balance equation. Meanwhile, you have already checked your equation that is balanced. You have 4 hydrogen here, 4 hydrogen here, 2 oxygen, 2 oxygen. Okay, so you have 2 moles of water at the top, 2 moles of hydrogen here. So this is your mole ratio section, right? So mole of hydrogen will cancel mole of hydrogen. Then you have mole of water here. You must always have mole of water. And anytime you're looking for mass, it's always 1 mole, either at the top or at the bottom. Remember here, you're looking for 1 mole of hydrogen. That is how you got 2.016 grams, because remember, hydrogen is diatomic. It's always 1 mole. And here you're also looking for mass of water, which is 18.02. That is, you look for 2 hydrogen plus 1 oxygen. Oxygen is 16. Hydrogen is 1 times 2, that would be 2. That is 2.02 plus 16, that will give us 18.02 grams. So the mole of hydrogen will cancel mole of hydrogen. What you have left is 8 times 1 times 2 times 18.02. You multiplied all the tops, write the answer down, divide by the bottom, 2.016 times 2, and that will give us 71.5 grams of water. Now, the same way you did for hydrogen here, you're going to do the same thing with oxygen. So you are given 24 grams of oxygen. That goes to the corner right here. So you have 24 grams of oxygen. Remember, the grams of oxygen will also be at the bottom, so that the grams of oxygen will cancel grams of oxygen. And remember, oxygen is 16, because oxygen is also diatomic. It's going to be 32 grams. So mole of oxygen will cancel mole of oxygen. And this is your mole, grams to mole. And this is also your mole ratio, because you have 2 moles of water and 1 mole of hydrogen here. So the mole of oxygen will cancel mole of oxygen. Mole of hydrogen, mole of water will cancel mole of water. Remember, water is 18 grams, just like the one you did for hydrogen. Is the same thing. You are producing the same product. So you multiply the top, 24 times 1 times 2 times 18.02 divided by 32 will give us 27.0 grams of water. So comparing the two answers, you discover that this is the smaller amount. So that means you can only produce 27 grams of water, and oxygen will be out. You will not have any oxygen left again, because you have already used all the oxygen that you have in the reaction. So oxygen is your limiting reactant. This 71.5 grams of water is not possible. You cannot get this, because you already ran out of oxygen here. At 27 grams, the reaction will stop. So there is no possibility of getting 71.5 grams at all of water. So in this case, your oxygen is your limiting reactant. Please go over this step one by one again And then if you have any question, remember you can always reach me on the Google Classroom or through my email. So this is your ticket at the door. Make sure you read the question very well. After the 2 questions, you have A, B, C on each part. Send it to my Google Classroom. If you have any question, don't hesitate to send me an email and I will respond to you as soon as I get your email. Alright, that will be it for today. I don't want to give you too much for today. Just go over these notes, put them in your notebook, review them, practice them, and answer the ticket at the door and send them back to me. Thank you for listening. Enjoy the rest of your day. Bye.